Alright, today we're going to talk about triangles. Or we can call them three-sided polygons. I suppose you could call them a threegon, we call them a triangle. And again, a polygon has straight segments and it is enclosed. But from our last video we know we can classify triangles by angles. So you look at the board and you can tell all three angles, C, B, and A, are all under 90 degrees. So we can look at triangle ABC and say that it is an acute triangle. All the angles are under 90 degrees. We also now can classify triangles by sides. And when all the angles are different, all the sides are different lengths. That is called a scalene triangle. All sides are different lengths. So if I use tick marks, none of the sides are the same. And the tick mark indicates an independent length. This length is not the same as this. It's not the same as that. So now we can classify a triangle by angles and sides. We can say triangle ABC is an acute scalene triangle. So are all scalene triangles acute? The answer to that is no. All scalene triangles aren't acute. We can have triangle DEF, and triangle DEF here has one angle, angle D, greater than 90, so that is an obtuse scalene. Angle E, angle F, and angle D are all different, but D is greater than 90, so it is obtuse and scalene. On the other figure, triangle HJK, we have a right angle shown. It is perpendicular. Segment JH is perpendicular to segment HK. That makes this a right scalene. And again, from the tick marks, you can tell all the sides are different lengths. So when all the sides are different lengths, we have scalene. Well, what if two sides of the triangle are the same? When we have two sides the same, we have an isosceles triangle. Again, that is when you classify it by sides. Again, we also can classify by angle. So we can have an acute scalene triangle, which again I could call ABC in this case. And I could say triangle ABC is acute scalene. You can tell two sides are the same by the tick marks. That AB and BC are the same. It also means that the opposite angles, angle A and angle C, will be identical. These angles opposite the sides. And so now we can also classify isosceles triangles and have a right angle inside one, which makes this a right isosceles. Again, meaning the opposite angles are identical. And finally, we can have a situation where one angle is more than 90, making the triangle obtuse, but two sides are still the same, and have an obtuse isosceles. And again, the base angles, or the angles across from the equal sides, are equal. The last type of triangle, no sides equal, two sides equal, is three sides are equal. And we call that an equilateral triangle. And you kind of see the word equal almost in there. It's kind of spelled the same. And that simply means all three sides are the same length. All right? All sides, same length. Well, think about what we talked about the last board. If the sides are the same length, what do you know about the angles? In an equilateral triangle, all the angles also have to be equal. Some people sometimes call it an equal angular triangle. In our classroom, we'll typically call it equilateral, but they're correct when you say all the angles are equal. And as we go forward, we're going to learn that, or review that, this triangle has 180 degrees. We actually know in an equilateral triangle, 180 divided by 3, that each of the angles is equivalent to 60 degrees. And this is the one case where we don't have to say acute equilateral. When we have an equilateral triangle, we know it has to be acute. You cannot have a right equilateral or an obtuse equilateral. So we just identify it by the one word, equilateral. Again, we talked about how to classify triangles now by not only angles, but now sides. So for angles, we have acute, right, and obtuse. And for sides, we have scalene, all different sides, isosceles, 2 equal sides, and equilateral, 3 equal sides.